So let's move some square root graphs, square root functions horizontally. To move them left and right, or knowing when to move them left and right, is knowing when that addition is, or how that addition and subtraction is being represented in relationship to the radical. See how we have the plus 4 underneath the square root sign, and then we have the minus 1 underneath the square root sign, and the same rules apply. If we have plus 4, that graph is going to shift that parent function. Everything moves to the left 4 units. And notice we still have the same relationship right here. See how we have that 0 right there? And watch this. Not from 0, 0, but from here. See, if I go 1 to the right, it's like taking the square root of 1, and the square root of 1 would be 1. So I'd have a spot right there. Hit the reset button back here to this spot at negative 4, 0. The square root of 4 would be 2, so notice if I go 1, 2, 3, 4 to the right, which I'm at the origin, I can go up 2 because the square root of 4 would be 2. I could repeat this process, and notice the next time that would actually happen is if I'm a total of 9 units away from that spot right there. Does that make sense? Okay. And so then, that's how that one works. The second one right there, x minus 1, because it's a minus 1, we're going to move everything to the right 1 unit. So moving this to the right 1 unit, there's my new spot right there, the square root of 1. Notice even though I'm underneath the 2, try not to look at those numbers. I said this before in previous units when we were graphing quadratics with that quick way of graphing it. The worst place you can possibly look is looking at those numbers down there on the x-axis and the y-axis. Instead, count the squares, because you know what the square root of 1 is. So if I go 1 square to the right, the square root of 1 would put me up 1. The square root of 1, 2, 3, 4 squares would put me up 2 more squares, just like that, and so on and so forth. Sometimes you might not be able to get all those to fit. We're going to see that in the next problem down here. Okay, so now let's take a look at these. First things first, let's get that parent function written down there. So let's graph that parent function. Okay, pause for a minute there while you get that one written in. Get that first dot right there, right? Square root of 0 is 0. Square root of 1 is 1. Square root of 4 would be 2. And then go ahead and dash line that one in, because we know it's not a part of our correct answer there. And now let's color code these ones. Let's make my first one go in here in blue. So if I want to graph x squared, the square root of x minus 3, that would be a translation 3 units to the right. So all these 3 points right here, get to move them to the right 3 units. So if I move them to the right 3 units, there we go. And this is the situation I'm talking about here. See, if I'm looking at this spot right here, the next dot that I would get, 1 squared would be 1. But then if I went 1, 2, 3, 4, see how I'd go off the graph? That's okay. Sometimes that might happen. Okay? And then for the next one, if we're looking at y is equal to the square root of x plus 2, that's going to move that graph 2 units to the left. So the parent function, that one there in green, everything got moved 2 units to the left, 2, to the left 2, and to the left 2. And then there's that graph just like that. So horizontal translations, really no different than vertical translations. Graphing calculator would definitely be worth a look right here to see in those situations. Now it would make sense to do that square root of x and then put the minus 3 in parentheses and then close it. And now we can move that graph to the right 3 or to the left. So notice how we have to properly put those in there. Okay, so that's how we end up graphing these horizontal translations. Now let's start to mix it up a bit and start to put in some of the vertical stretching or possibly reflecting of the graphs.